This paper is about in-context learning and what roles explanation plays in that. So the question this paper asks is, can language models learn from explanation in context? So let's go to the setup. So this is the overall prompt and is given to the language model. It is frozen. So this is in-context learning, and so this is an example of question answering task. So this has an instruction, a question, and an answer, an explanation about the answer. So usually earlier work has explanations or reasoning steps before the answer. This one is after. So gray and blue is one set. This is one shot, and they have four more examples plus explanation. And target question is a question and an answer. There is no explanation for this. They're using model from 1 to 2 and 280 billion parameters, Gopher. In context, they are using 0 and 5 shots. Dataset is a subset of big bench datasets. So it's a 40 tasks which are chosen based on 4 constraints. Let's discuss what those 4 constraints are. The overall prompt should not exceed the context window of our models to 2048 tokens. The target should be multiple choice and in JSON format. The explanation should make sense. It should not be just the restatement of the answer. The few shot performance of our largest model should be sufficiently low that explanation should plausibly offer some benefits. Okay, so these are the 4 constraints for selecting 40 tasks. So now we know. So they have multiple choice. So they evaluate like what's the maximum likelihood of selecting an option, and based on that they have accuracy as their metric. Okay. For annotation, they what they do is they take they have single author annotate 15 randomly chosen task examples that's appear from each dataset with expert explanation that would help a human to understand the relationship between the question and the answer. So they do 15 for each task. Now they have some variety of the explanations where they want to, because they want to see how explanation helps. So they want to see whether semantically right explanation helps or some scrambled words are enough. So to have that evaluation, they have 4 varieties plus 2 more. One is scrambled versus non-scrambled. They keep the length of the prompt same, but they scramble the words. Second is the explanation, which doesn't explain the answer, but it's from the same domain. Third is there are 4 shots, right? So there are 5 short. So they take the 5 explanation and shuffle them. So okay. And instruction versus non-instruction means that they replace the instruction with some random instructions. So it's not related to the task. Yeah, that's what they're saying here. Evaluation, they have some different range. So for task instruction, either they have none, no instruction, task instruction, and non-instruction means some random instruction. They have explanation, none, other item explanation, non-true explanation, and scrambled explanation. Okay. And they have 2 more varieties. One variety is selecting the examples. So what they do is now they have like 15 annotations. So out of 15 annotation, they greedily select 5 of them so that it has the highest performance on the rest of the other 10. Okay. So they select that and they call it selected examples. Hand tune means you have that highest performing original explanation prompts and then you further tune on it. Okay. So you select the greedy thing and then you further tune on that example. So that is hand tuned. Okay, so results. Let's go on the results. So this actually tells you individual contribution of the individual components. So the starting is only a question, target question and answer. So if you add some future examples, it's gonna give you a big boost. And then if you add untuned explanation to it, it's gonna add this much performance more. So it's like around 20%. So it's like 70% plus 20%. So that's the overall performance. Okay. And this is with and without instruction. I mean, it's an average of these two settings. So that's the thing. That's the performance here. If you see here, the other item explanation to all the other conditioned explanations have either improvement or they are deteriorating the performance. Hand tuned. Okay, so anything which is selected or basically what involves more labor, human labor, and which are more tuned versions, or either in selecting the examples or tuning the explanations, they are gonna boost a lot. Okay. Instruction and non-instructions is like the instruction provides a little bit of boost, but not a lot. So this paper also points out this that earlier research shows that research has a very very important role and it gives you a huge boost, but here they are saying that it doesn't. In fact, the other part of the prompt gives more benefit, like explanation. They have another plot where it's a comparison between. So this is a plot which compares the improvement that explanation caused relative to matched prompts without explanation in three different conditions. So what it means is, so the x-axis is improvement in log score, the y-axis is density. So untuned version has like most of the tasks have like zero, most of the tasks have zero improvement, but like many have some improvements, like the density over here is more than the density over here, right? So many of them have improvements. Selection with explanation, selection without, it means that we are greedily selecting the examples, so it actually boosts the performance for many of the tasks. Hand tuned, they're not many hand tuned, but whatever they have, it shows like the maximum boost in the performance. Okay. So there are some more analysis. This is only large model benefit from explanation. So this is about a number of parameters in the model, and this is average accuracy. So this is average accuracy over 40 tasks. Okay. So the yellow one is just the 5 shots without any explanation. Okay. The purple is 5 shot plus untuned explanation. So if you see here, as the model parameters grows, the difference between these two increases. So what they're saying is, for larger models, there is like the explanation plays more major role in deciding the performance. Then this is like selecting 5 shots plus, so this is like greedy selection plus 5 plus explanation, and this is just selecting the 5 shots and not and there is no explanation. So it's gonna give you a boost. So they just have like they just do it for 280 billion parameters. Similarly, they have there's some other varieties here. So the purple one is 5 shots plus untuned explanations, which gives you a huge view boost as the parameter grows. The others, I mean, if we see like very small models, they all kind of perform the same. There's not much distinctions, but as it grows, there's a like comparably more distinct behavior from these explanations. They also have analysis across different domains. So like in every, so they have the same plots, and most of them shows kind of similar format, that having no difference in the small models and having some difference in the bigger models. Some exceptions, like computer science is one exception. um, this is also some exceptions where it actually decreases, which is, I don't know, strange. Yeah, so that's the overall uh, analysis. um, so let's see. So we found that the effect of task instructions was smaller than the few short examples, or so that's their idea. One of the conclusion, that the effect of instructions is smaller than that of explanation. This may be due to prior work tuning instructions heavily on performance, thus making the prompts arguably not zero shot, or may relate to the task on which we evaluated, which we sampled adversarially to be challenging. Okay, so what is the relationship between? Okay, so the other conclusion is the largest model shows a significant advantage for real explanation, even relative to this closely matched control. In fact, the control appears no better than the prompt without any explanation. This suggests that the largest model is making use of the relationship between the examples and their corresponding explanation to generalize better to the target question, rather than simply relying on distribution of the words or sentences in the prompt. Those are like the major conclusions, that the explanation helps for the larger models, and explanation has much more weightage than the instruction. So that's the overall um, conclusion. And there are more there are more about there are more statistics about uh, how they have analyzed the individual contribution of the individual components contribution to the prompt, so you can have a look at it. So that's all for this paper. Thank you.